वेलकम एवरीवन टू द सिक्स्थ सेशन ऑफ रिस्क एक्सप्लोर। एंड आज का हमारा एजेंडा है ऑप्शन प्राइसिंग। वी विल सी दैट हाउ वी कैन प्राइस द ऑप्शंस, कॉल एंड पुट ऑप्शंस इन डिफरेंट वेज। एंड we will price nifty 50 options, nifty 50 call and put options. So let's get started. As the first step, what we will do, हम सबसे पहले निफ्टी का हिस्टोरिकल स्टॉक प्राइसेस का डेटा वी विल फेच यूजिंग स्टॉक हिस्ट्री फंक्शन, जो कि हमने फिफ्थ सेशन में भी डिस्कस किया था. So for fetching the price data of any stock or index, which function can we use here? Which function can we use here? We discussed that in the last session as well. Correct. It is a stock history function. So हम use करेंगे stock history equals to stock history, and as stock we will provide in double quotes Nifty. Close the bracket, comma, we will also give the start date. So let's say as a start date हम देते हैं 2001, month 1 and day 1. Now to dynamically get the end date, we will use today function, ताकि हमें latest date मिले, आज की date मिले. So today function, comma, interval will be, let's say, daily. So we will use 0 here. Then we don't want headers, we already have them. Date and close, हमने ऊपर already headers को include कर लिया है. So we will go with no headers, comma, first property that we will go with is date, and then close price. Close the bracket, press enter, and we have the historical prices or the historical levels of Nifty for the past 25 years, right? So हमें निफ्टी का डेटा मिल गया है, यहाँ पर स्टॉक प्राइसेस का डेटा मिल गया है. नाउ वी हैव टू derive the log returns. We have to derive the log returns. Again, we did this activity in the past few sessions. So for that, we will just use ln, correct, ln this divided by this. So इससे हमें रिटर्न मिल गया, बट दिस विल नॉट बी डायनेमिक. दिस विल नॉट बी डायनेमिक बिकॉज इसे हमें ड्रैग करना पड़ेगा, राइट? इसे हमें ड्रैग करना पड़ेगा. सो हाउ टू मेक दिस डायनेमिक, कंप्लीटली डायनेमिक, सच दैट यहाँ पर अगर आप अपनी डेट चेंज करते हैं, सो ये डायनेमिकली चेंज होगा, लॉग रिटर्न्स भी आपका चेंज होगा. सो फॉर दैट व्हाट वी कैन डू, we can use we can use drop function, drop from this, right? Drop from this, comma, first row. Okay, now again this is not dynamic, so इसको हम कैसे डायनेमिक कर सकते हैं? Using choose calls function, this, comma, 2. So now this is dynamic as well. If we closely look at this, what is this? Basically this is the current value. If we see, this is the current value, right? We have skipped the first value here. अब अगर हमें इसके जस्ट सामने, इस करंट वैल्यू के सामने हमें प्रीवियस वैल्यू चाहिए, सो व्हाट वी कैन डू, वी कैन कॉपी द सेम फॉर्मूला, कम हियर एंड पेस्ट दैट हियर. नाउ इंस्टेड ऑफ ड्रॉपिंग द फर्स्ट रो, वी कैन ड्रॉप द लास्ट रो. सो जैसे ही हमने लास्ट रो को ड्रॉप किया, व्हाट वी हैव गॉट अगेंस्ट ईच अदर, वी हैव गॉट द करंट वैल्यू एंड द प्रीवियस वैल्यू. करंट वैल्यू, राइट, करंट वैल्यू, एंड इसी के सामने हमें क्या मिल गया? प्रीवियस वैल्यू. नाउ इफ वी डिवाइड देम, so if we divide the current values by previous values, and इसके सामने अगर हम ln function का यूज कर लेते हैं, then we will get the log returns. So the logic of choose calls is, this is an array, right? This is an array. आपको यहाँ पर blue border दिख रहा होगा इस array के अराउंड. Can you see the blue border around it? Yes. And वो blue border के अंदर कितने कॉलम्स हैं अभी? It has 2 columns, right? 2 columns and multiple rows हैं. Now we have to dynamically select the second column. Dynamically select the second column. So उसके काफी सारे ways हो सकते हैं. The easiest and the most convenient way is to use choose calls function. So choose calls from this array. इसमें से हमें कौन सा कॉलम सेलेक्ट करना है? लेट्स से मैं अगर 1 यहाँ पर इनपुट करता हूँ, सो इट विल गिव मी द फर्स्ट कॉलम इन रिटर्न. अगर मैं यहाँ पर 2 इनपुट करता हूँ, So it will give me the second column in return. Okay, so this is how choose calls work. And similarly यहाँ पर मैं let's say 2,1 देता हूँ. So what it will do, it will first return me the second column from this array and then the first column. And why this is dynamic? Because of this pound sign here. So जैसे ही आप पाउंड साइन का यूज करते हैं या जो भी डायनेमिक एरे है, योर कंप्लीट आउटपुट गेट्स डायनेमिक इटसेल्फ. ओके, सो यहाँ पर हमें लॉग रिटर्न मिल गया है डायनेमिकली. नाउ व्हाट वी हैव टू डू, वी हैव टू कन्वर्ट दिस इनटू अ सिंगल फार्मूला. सो सिंगल फार्मूला में कैसे कन्वर्ट कर सकते हैं? अगेन वी विल कॉपी दिस पार्ट हियर. E8 के अंदर क्या फॉर्मूला था, E8 हैश के अंदर क्या फॉर्मूला था, वो हम यहाँ पर पेस्ट कर देंगे. नाउ सेकेंड पार्ट वॉज दिस F8 हैश. सो अगेन what we will do, we will go to this cell here, copy this formula and paste that here, press enter, and हमें log return मिल गया. Now we don't need these two columns. This was just for our understanding. Now what we can do, we can copy this and paste that here. So हमें dynamically log returns मिल गया. How this is dynamic? Let's say instead of 2001, let's go ahead with data from 2011 onwards. So जैसे हमने 2011 किया, you can see that the log returns are dynamic as well. हमें कहीं नीचे ड्रैग नहीं करना पड़ रहा है, हमें इसको एडजस्ट नहीं करना पड़ रहा है बेसिकली. ओके, आई विल प्रोवाइड बोथ द वर्जन्स. हम अभी डायनेमिक वर्जन ध्यान में रखते हुए इसे प्रिपेयर कर रहे हैं. आई विल ऑल्सो प्रोवाइड अ वर्जन जिसमें इफ यू डोंट हैव एक्सेल 365 और एक्सेल 2021, then also you can post your results and do the analysis. So I will provide both the versions. So this is the benefit of using log returns. Similarly, अगर हम उसके भी पहले जाते हैं, let's say 1990 में जाते हैं, so then as well it will work. So you can see it is completely dynamic now, and we have dynamically generated the log returns here. So formatting हमें अपने आप ही change करनी पड़ेगी. It doesn't get automatically changed. So we have the historical returns of Nifty here. Historical log returns है हमारे पास में. Now we have to find out the SD, volatility. So how do we find daily volatility? How do we find it? Using which function in Excel? Correct, standard deviation. And since this is the complete historical data of Nifty 50, we can go ahead with the population function as well. So now which function can we use here? Standard deviation, population as well we can use. And we can select this complete range here. Now automatically जैसे ही हमने इसे पूरा select किया, since this was dynamic, we are getting a pound sign here. And this is how we can create entirely dynamic output. So यहाँ से हमें standard deviation मिल गया. Now this is daily standard deviation. In order to convert this to annual SD, what we can do? How do we convert it to annual SD? Correct. We multiply it by square root of 250 or 252 into square root of 252. So we get annual volatility as well here. Okay. Now what we have to do, we have to also find out the latest price, right? Latest price that we have for Nifty 50. Latest price क्या होगी? If we go down, we can see this is the latest price. Okay, this is the latest price right here. But the challenge here is how to fetch it dynamically. How to fetch it dynamically. So there are multiple ways we can handle this. One way could be that we can use VLOOKUP function here. VLOOKUP, and VLOOKUP हम कैसे करेंगे? Today's date. Okay. Where we will VLOOKUP? We will look up here, right? कॉमा कॉलम इंडेक्स हमें कहां से कौन से कॉलम में से वैल्यू चाहिए? सेकेंड कॉलम में से. एंड वी विल यूज एग्जैक्ट मैच हियर. सो वी विल यूज फॉल्स हियर, और वी कैन यूज जीरो एज वेल. False or zero, they are the same thing. Press enter, and we are getting an error. The reason is because 24th तक ही हमें वी हैव द डेटा अवेलेबल, सो ये जरूरी नहीं है कि आप आज की डेट को ही सर्च करेंगे और आपको स्टॉक हिस्ट्री डेटा के अंदर आपको रिजल्ट मिल जाएगा. दैट इज नॉट नेसेसरी. So what we can do is we can go ahead with approximate match as well here. We can go ahead with true here, and we can see the closing price is 25,795, and we have the same price here as well. Okay, this is one of the ways in which we can fetch the latest closing price here dynamically. Other way could be that we can use a combination of index match function or choose calls choose rows function. So what we can do is we can use choose calls function. So सबसे पहले हम इसमें से second column को select कर लेंगे dynamically. We have the second column here. Now from this we have to dynamically fetch the last row. Dynamically fetch the last row. Last row को कैसे fetch कर सकते हैं? Using again choose rows function, and last row हमें since fetch करनी है, so we can use -1 here. So that also gives us the same answer. So is it clear until here what we did to fetch the closing price? We used VLOOKUP, and used a combination of choose rows, choose calls here. We can also use a combination of drop and take function as well. So take from this the last column -1 and take the last row as well. So this also gives us the same answer. Using take function as well, we can fetch the closing price dynamically. Why -1 in choose rows? So basically -1 का मतलब क्या है, आप लास्ट से लास्ट रो सेलेक्ट कर रहे हो. -2 का मतलब क्या हो गया, सेकेंड लास्ट रो का आप वैल्यू फेच कर रहे हो. So that is the meaning of -1 -2. Okay, so we have all the three alternatives here in order to fetch closing price. Now we have the closing price. Similarly, we have the dividend yield as well. Dividend yield of Nifty 50. Nifty 50 is also composed of 50 stocks. So what is the current dividend yield? It is 1.3 here, 1.3% here. So if I unhide this sheet here, this is the data we fetched from the index, right? We scrapped it from index, and index itself gave us this value. We can see dividend yield 1.3 here. So if we have a look here as well, this is the same thing we have done here. We have just divided it by 100. Okay. We fetched all this data from Nifty 50's website, and similarly, we fetched this option chain as well. We will discuss it later on. So let me hide it again. And now we have all the components, and we can proceed and work in this sheet here, that is option pricing. Okay. Now we will move on to option pricing basically. So let's fill in these values here. Let's fill in these values here, and then we will see कि कैसे हम simulations की help से value को derive कर सकते हैं, and likewise how we can derive it using closed form solution, that is Black-Scholes-Merton model. So let's get started. सबसे पहला इनपुट है यहाँ पर हमारा S0, that is the spot price. So can you tell हमें यहाँ पर क्या इनपुट करना है? अभी हमने उससे फेच किया था. So what we have to get here? Correct. Everyone is correct. So we have to get the latest closing price of Nifty. So हम यहाँ क्या कर सकते हैं? We can refer it directly from here. Okay, today's price, correct. Now second input that we need is strike price. So strike price, we can choose anything. We can choose any strike price, right? So if I again, let's say, unhide this, so you can see we have these list of strike prices available. It could be at the money as well, in the money as well, out of the money as well. So कोई सी भी strike price हम select कर सकते हैं. So what we can do is we have created a mini option chain here in Excel, and here we have taken this as the strike price. Basically, let's go ahead with this strike price here. Okay, 25,900. So हम इसे select कर लेंगे. We can refer from here as well, 25,900. Okay, this is the strike price that we have here. Now risk-free rate, we need risk-free rate as well. So let's say we take this as 6%. 6%. But for purpose of option valuation, option pricing, we have to take it as continuous compounded rate. So for that, what we can do, we can use ln function, ln of 1 plus this. So we will get continuous compounded rate here. Another thing we need is volatility. We have derived that here, volatility, annual volatility. So we have that here now. Now current date की जगह हम क्या यूज कर सकते हैं? We can use today's date, right? We have today's date here. Similarly, maturity date. Maturity date means कि हमारा ऑप्शन कब एक्सपायर हो रहा है. When is our option expiring? Okay, if we have a look at this option chain here, there are options available for multiple expiries. Let's say this is the expiry for 28th October. There is another option which is expiring on 4th November. So likewise, we have different maturity dates. So accordingly, we can choose as per our need. So let's say we go ahead with this one, 4th November, and let's refer this 4th November from here. Okay, and also use date value function before this in order to convert this into a date, right? Because right now, since we have this list of dates here, these are text here. So what we did basically, we converted this into a date using date value function. Okay. Now we need time to maturity in years. So you have to tell me how we can derive time to maturity using current date and maturity date. How can we derive time to maturity in years? Difference by 252. Date diff. Okay. Any other thoughts what we can do here in order to derive time to maturity in years? Okay. So the answer to this is that first of all, we have to take the difference, right? That is certain. We have to take the difference here. Now, the difference here is 9 days. The difference here is 9 days. That means आज की डेट और मेच्योरिटी डेट दैट इज 4th नवंबर के बीच में कितने दिन है? 9 दिन है. Now the question is, do we have to divide it by 252 or 365? Should we divide it by 252 or 365? The answer is that we have to divide it by 365. Why? Because 252 क्या है? It is the trading days available. क्या जब आप यहाँ पे डिफरेंस निकाल रहे हैं, आर यू कंसिडरिंग द फैक्ट कि ये 9 के 9 दिन आर द ट्रेडिंग डेज? इसमें से कुछ बीच में वीकेंड्स भी हो सकते हैं, सैटरडे संडे भी हो सकते हैं, राइट? सम मार्केट हॉलीडे कैन बी देयर एज वेल. सो दिस इज कंसिडरिंग ऑल द डेज इन अ ईयर. ये जो 9 दिन है इसके अंदर सारे दिन इंक्लूडेड है. इट इज नॉट एक्सक्लूडिंग द नॉन ट्रेडिंग डेज. सो डिनोमिनेटर में भी क्या आना चाहिए? वी हैव टू कीप द सेम यूनिट्स इन न्यूमरेटर एंड डिनोमिनेटर. सो डिनोमिनेटर में क्या आना चाहिए? It should be 365. Okay, it should be 365. And we have time to maturity in years here. So yes, you are correct. Basically that is the point. Your expectation of volatility and market's expectation of volatility, that is how you can exploit the arbitrage opportunity. So basically ये हम अज्यूम कर रहे हैं, वी आर अज्यूमिंग दैट जो हिस्टोरिकल वॉलेटिलिटी रही होगी वो भी आगे जाके रहेगी. दिस इज वेयर यू हैव टू give in your own inputs, and we will see that why the pricing by the model given us here and the pricing from the option chain, they are different. Why they are different, we will see that these inputs are the reason. So your judgment of volatility, we are just assuming that ki jo history mein rahi hogi volatility, that will be the same volatility going ahead as well. But you can assume anything. आपका expectation हो सकता है कि historical से ज्यादा हो, कम हो. So that is individual call. But right now we are just assuming कि ये historical volatility ही आगे sustain करेगी. So this is one way of deriving time to maturity. Another way is using year frac function. Using year frac, and this is the start date, right? This is the end date, and we can give in the basis as well. So let's go ahead with the third one, because this is what we have used here as well, divided by 365. Press enter and we have got the same results. Correct. We can use solver. We can use solver to derive implied volatility. What you have to do, basically, you have to derive implied volatility such that your model's price matches with that of the actual price in the market, right? And that will give you the volatility that matches the market price, and accordingly you can derive it. Okay. So we have got time to maturity here. Now dividend yield. So dividend yield again, as we have here 1.3%, 1.3%, and this as well we have to convert it to continuous compounding. So 1 plus ln of 1 plus dividend yield. Okay. And the last input is that how many simulations do we have to do? कितने simulations हमें करने हैं? So let's say we go ahead with 1000 simulations. Three is basically, you can see that there are different bases here in ERFREC function. 0 means that you are using this convention, date count convention, 30 by 360. 1 is actual by actual. So we have opted for 3 here because we are assuming that in a year there will be 365 days. Okay. So we have time to maturity. We have dividend yield and we have simulations. Now we have all the required inputs to simulate the stock prices, future stock prices, right? So for simulating future stock prices, we will use this formula here. We will use this formula here. We will not go into uh, the depth of understanding this formula, since that will be part of theoretical coverage in FRM course. We will only see that how to implement this dynamically in Excel, right? So if you see here, there are many inputs we can directly use from here. So one is S0, we already have S0. Then we have R as well here. We have Q as well. We have sigma as well. We have T as well. This is T basically, right? Time in years. We have to now fetch Z here. Z here. And Z is the component that makes this entire exercise random. Okay. So Z will be, how to derive Z? For that we will use norm S inverse, norm S inverse, since we can see that it follows normal distribution, and we have to give in the values between 0 and 1 here into this function. So how to derive random values between 1 and 0? How to derive random values between 1 and 0? Which function can we use here? Okay, one option is rand function. What are the other options we have explored in the past sessions? Correct. We can go ahead with rand array function. Excellent. We can use rand array function. Since we are doing everything dynamic, so we will go ahead with rand array function. So equals to rand array. How many simulations do we have? 1000 simulations. So we will generate 1000 random numbers. We have 1000 random numbers here. If we press F9 key, we can see that these random numbers are changing. Okay. And now we have to feed these random numbers, random probabilities inside norm as inverse function. So it will give us value of Z, value of Z here. We have random values of Z here. Now using these values of Z and this formula here, we will derive ST. We will derive ST. How do we do that? Again, we just have to follow this formula, equals to S0 multiplied by exponent of, correct, by default it gives us values between 0 and 1, rand array function. So S0 multiplied by exponent of within brackets we have R here minus Q here minus half sigma square. So for half, we can use 0.5 into sigma square. Okay, sigma square multiplied by this within bracket and then multiplied by E here. Okay, plus into sigma into square root of time, square root of time multiplied by Z. So we have Z in H4 cell. To make this complete thing dynamic, what we can do, instead of referring to H4, what we can refer to, अगर हमें इसे पूरा डायनेमिक बनाना है, instead of referring to H4 only, what we can do, excellent, we can use H4 function directly. It follows BODMAS. Excel follows BODMAS. So we will use H4 hash here, जिससे पूरी रेंज एक साथ में सेलेक्ट हो गई Z की. Let's close the bracket, press enter, and we have the terminal prices of Nifty. We have the terminal values of Nifty. Okay, if we press F9 key, you can see that these are all the different possible values that Nifty can take in the next 1 year. Or we can say that on 4th November, since we are dealing with this T here, T in years, right? So these are the terminal values possible on 4th of November. Okay. Now we have to find out call payoff and put payoff. So just by looking at this value, 25653, if we are standing on 4th of November, you have to tell me that will it be profitable as a call buyer or a put buyer? As a, it will be profitable as a put buyer. Why? What is the reason? What is the reason? Correct. Excellent. Since this value is less than the strike price. Since this value is less than the strike price. So what will be our rule here? Equals to if this value, if the terminal prices are less than strike price, if they are less than strike price, what we will have to do, we will have to get the difference between this minus this. Otherwise we have to get 0 here. Since अगर ये values के ऊपर होती तो 0 pay off होता. Okay, press enter and we have the result here. We have the results here. Similarly for call payoff, what will be the rule? That if the terminal prices are greater than strike price, then हमें क्या चाहिए? Terminal price minus strike price, otherwise we want 0. Okay, simple rules. Correct, simple rules. You can see that this value here is greater than 25,900. So we are getting call payoff here and put payoff is 0 here. See, that is the advantage of using dynamic arrays. We don't need to freeze anything. You have noticed that we didn't freeze anything here. हमें उसके बारे में चिंता करने की जरूरत नहीं है. Everything is dynamic. You don't have to worry about fixing anything here. Okay. So now we have all the required inputs here. We have all the uh, required data here. Now let's go ahead and let's calculate the discounted call price here. If we press enter on, it won't change since it is. No, it will change if you like press rand array here, it will change. So we have the call payoff and the put payoff here. We have them here. Now what we have to do, we have to find out the average payoff here. Average payoff of call here. So how do we do that? We use average function here and we select this array. Close the bracket, press enter, and we have the average value of call here. Similarly, we can find out the average value of put as well. The average of put, we have the average values here. But there is one thing missing here. What is it? There is one thing missing here, which we didn't consider. Correct. Excellent. We are missing discounting here at RF. Correct. We have to discount this as well. So for discounting, what we can do, we can multiply this by exponent of minus RF multiplied by what we will multiply RF by. हमें RF को किस से multiply करना पड़ेगा? For which period do we have to discount this? By T, time to expiry. So we have to multiply this by T here. Enter. And we have the discounted value of call here. Similarly, we will use the same component here as well. Press enter. And we have the discounted value of put as well here. Okay. Now we have to find out the standard error. So standard error के लिए we have to find out the standard deviation of call payoff. And standard error का formula क्या होता है? We have to divide this by square root of n. Square root of n. And this is the n that we have. Close the bracket. Press enter. We have standard error here. And again, this as well we have to discount. So we have the standard error here. Similarly, to find out the standard error, let me check if I have referred. Okay, correctly referred. Now, similarly, if we have to find out the standard error of put option, we can use standard deviation function, put payoff divided by square root of n and multiply by the discounting factor. So we have standard error as well here, right? This is the value. This is the pricing that we have derived using simulations. We have done 1,000 simulations. Let's compare this with the actual prices in the market, actual prices of call and put in the market. So if we see, this is the value of call option 313, 313. And if we see here against 25900, we are far off from the value in the market here. And one of the reason of that is that if we check out the implied volatility here, IV here, it is 9.89%. But what have we used here in the inputs? We have used the volatility almost more than double, right? More than double volatility. So that is one of the reasons. And there could be many more reasons, right? There could be many more reasons. So you have to give in your own estimate of volatility here. It might not be necessary that you have to give the historical volatility only here, and that we did in this case here. We can give our own estimate of volatility. And similarly, if we see the discounted put value here, it is 442. If we check here, it is almost half year, more than half year, less than half year basically. Last traded price of puts. And the reason is again, we can see that IV here is around 10.54%. So let us do one thing. Let us try one thing. Instead of using this estimate of volatility, right, let's go ahead and let's use this estimate here of IV 10.54 divided by 100. If we now check here, discounted put की क्या value है? 199.63. And what is the value that we have here of put? It is 200 here, 200.95 here. So they are very, very close. right? They are very, very close now. Okay. So this is how volatility can play a big part here, right? Let's go back to the original value that we had here. So we have got discounted call and put values using simulations. If we press F9 key here, you can see that these values are changing, right? These values are changing. How to reduce the standard error here? What can we do to reduce standard error here? We can increase the number of simulations, जिससे जो values का की randomness है, that will decrease. So let's say we increase it to 10,000 simulations. 10,000 simulations हमने increase किया. Now if you press F9 key, you can see that they are close now, right? वो इतना ज़्यादा change नहीं हो रहे हैं. Standard error here is 5.22 and 5.49, which has drastically reduced, right? So जितना हम number of simulations बढ़ाएंगे, we will get to the we will get more closer to the actual result, actual value, right? Now similarly, let's use Black-Scholes model. Again, this is a closed form solution to price the options. So let's have a look at the formula, right? Let's have a look at the formula here. So this is the formula that we are going to use to derive call and put option using Black-Scholes model. So we have to derive these four values here. The first value that we will derive is D1 here. And for each of them, we have the description given here as well. That what are each of these variables. So for D1, the formula is within brackets, since there is numerator and denominator, we will use a bracket here for numerator and a bracket here for denominator. So let's work ahead with numerator. And for numerator, we have ln of S0 by K, S0 divided by K, right? S0 by K plus R minus Q plus half sigma square. R minus Q plus half sigma square. Okay. Plus half sigma square. And this whole multiplied by T. This is T here. So this is numerator. Denominator is sigma into square root of T. So sigma into square root of T. Press enter. We have value of D1 here. Similarly, what will be the value of D2? It will be D1 minus sigma into square root of T. We have D1 and D2 here. Now we have to find out value of call and put. So what will be the value of call here? It will be S0, okay, S0 multiplied by exponent of minus Q into T, minus Q into T. So what is Q? This, and into T here, into ND1. So if we see the definition of N here, it is cumulative distribution function CDF of the standard normal distribution. So what we have to use here? We have to use norm S dist, standard normal distribution, you can see here. And the value of Z will be D1, comma. We have to use cumulative as true here because this is CDF function, not PDF function. So CDF के लिए हमें true use करना है. We have ND1 minus K into exponent of minus R into T minus R into T into, again, norm as dist, z में हम क्या यूज करेंगे, d2, ओके, एंड कॉमा ट्रू भी करना है हम, close the bracket, press enter, and we have value of call here. You can see that using Black-Scholes model, we have got 330, and using Monte Carlo, we have got 327. They are very close here. If you press F9 key here, you can see that this is not changing. This will obviously not change. This is changing, but they are very close. And as we increase the number of simulations, so let's say we do it for 30,000 simulations, you can see they are very, very close. If we press F9 key here, they are very close at each iteration, right? So same formula, let's use it for put as well. So let's copy this. We have to do some alterations. First of all, we have to take this part after the second part of the formula. So minus this, okay. Then what is the adjustment that we need to do? We have to use minus D2 here, right? Minus D2 here and minus D1 here. We have 406 here, okay. We have 406 here, and it is very close to the value of put derived using simulations. So let's press F9 key, and you can see that both the values are very, very close, okay. Both values are very close, and like as we discussed earlier as well, we can derive the implied volatility as well here, volatility here, using the, by comparing the market price and the model price here. So using solver you can do that, okay. You can using solver you can do that, and you can see that okay, the IV of market is 9.89, but your your estimation of IV may be different. So accordingly, you can place your trades. Now, another thing is, this is your activity as well. What you have to do, you will get the complete file here. You have to do two things basically as your activity from your end. Using these relationships here, for each of these, you have to like observe by changing the values here. You have to observe and somewhere make a summary table that upon increasing the current stock price, if the current stock price increases, what is the effect on call and put price upon changing the strike price from this level. So you can consider this as the baseline level. You can take any of the other levels, right, and check the effect on call and put prices and see if it matches with the effects that are given here or not, okay. So you have to perform that kind of analysis, and secondly, you have to observe this option chain and make your notes, make your observations and make a note. And once you do that, you can post the entire thing on LinkedIn, and you can use this hashtag RiskXplore, hashtag RiskXplore, and you can also use hashtag peaks to tails or hashtag SSEI. So that's it for this session. Thank you so much for joining, and let's stay connected through the community, and let's have more sessions in future just like this. Thank you so much and have a great day.